Hi guys, it's Mrs. Glenn. This is the 1.4 video for, I don't know what it is. Hi guys, it's Mrs. Glenn. This is the 1.4 video for radical expressions and rational exponents. And let's just go over the exponents over the index. So this top number in your fraction will be your exponent that ends up being under the radical. This line is a square root that most of you guys know this as, but it's actually a radical. And so this will be your exponent, and the index will be your front root. So we're going to show what that looks like in a minute, but just remember it's exponent over index. So I labeled these all for you so you'll remember exponent over index when we make our radicals for each one. So let's take a look at the directions at the top. Use the properties of exponents to rewrite the following expressions with rational exponents as expressions with integer exponents or radical form. So your answers are either going to be with a radical in the answer, or it's going to be with an integer as your answer. So integers just mean a number. So let's look at the first one, 16 raised to the 1/2. So this will be your exponent, and this will be the front number in front of the radical. So your front number is the 2, that's your index, and 1 is your exponent. So when you have the second root of 16, that's the same thing as the square root of 16. This shouldn't have a line across it. This should just be 4. So when you do that, the square root of 16 is just equal to 4. So when you write this on your paper, don't have the line extend over the 4. Have it stop right here. Let's take a look at this one over here. So we have the third root of 27. So 3 goes to the front, that's your index. 1 stays as your exponent. And when you have the number in front, that tells you how many times the number is going to be multiplied with the answer to get this number. So we need to find a number that multiplies with itself 3 times to get to 27. So 3 is what actually does that. 3 times 3 is 9, and then times 1 more would be 27. So 3 times 3 times 3 is 27. And that's how you figure that out. So that's why this is equal to 4, because 4 times 4 is 16. And 3 times 3 times 3 is 27. So this little number tells you how many times you have to multiply this answer by in order to equal the radicand. The radicand is the number underneath this little house, or under the radical. So let's take a look at the third one. We've got 7 to the 3/4, so this is going to be your exponent, so we'll have 7/3 underneath. And this is your index, so you have 4 in the front. And 7 to the 3rd power you can put in your calculator. Use your exponent key, and that turns into 343. There is no number that will be the 4th root of 343. There's no number multiplied by itself 4 times evenly. Integers are your counting numbers. So it will be a decimal, but that's not what we're looking for. So we're going to just leave it like it is because it is not an easy radical to work with. The fourth one, 4 to the 3/2. This is your exponent, so underneath the radical will be a 4 to the 3rd power. 2 is your index, so that goes in front. We actually can calculate 4 to the 3rd power. That turns into 64. And remember what I said, whenever you have a 2, that's the same thing as square root. So you guys all should be able to do the square root of 64, which is just 8. All right, moving on to the next one. Rational exponent property. That just states that we're going to do the same thing as we did before, where we had our exponent stays on and our index goes in the front. But one more way that you can represent that is actually pulling the a on the outside and putting your radical on the inside. So it's the b root of x raised to the a power. So this is the same thing. And this property, rational exponent property, means that you can represent it in 2 ways. You can represent it like this or like this. So let's take a look at these. So now you're going to actually have some part of the answer is a rational exponent and some parts are not. So this first one has, remember, if it's just a square root, it's the same thing as having that little 2 here. So going backwards, now we're going to put that 2 as the index, which is the bottom number of the fraction, and the 1 will be at the top, which is your exponent, because it's exponent over index. So we have k to the 1/3 power, and then 4 just stays the same because we're not doing anything with that. You can't combine these two because they're not like terms. Second one over here, we have the third root, or the cubic root of b minus 7. So this whole thing is going to be b minus 7, and then the 3 is your bottom because that's the index. This does not have an exponent, so we automatically use 1, and 1 will be your top. So 1 over 3 because exponent over index. So b minus 7 raised to the 1/3 power. And just remember, going backwards, we put the 3 out front and the 1 stays on. So 3 goes out the front and the 1 stays on. So this one, exactly the same thing. If the 3 is in the front, we know that's the bottom. The exponent, because there isn't any, is going to be a 1. So exponent over index, so it's y to the 1/3. Then this one, it's the same thing except for this is a 5 here. So instead of it being a 3, we have a 5. So we're going to put this entire thing, just like we did here in parentheses, and you're going to raise it to, what do you think? What fraction should you raise it to? If we raise this one to a 1/3, then this one's going to be raised to the 1/5. And then the minus 2 just stays on like it is. So g plus 4 raised to the 1/5 minus 2. Okay, so now you're going to do some matching. So x to the 5th power, remember there's an imaginary 2 in front, is the same thing as having x plus 5 raised to the 1/2. And then we have b, which is 5 to the 1/3 power. Remember the 3 is your index, so that goes in the front. So look for the answer that has 3 in the front. This one does and this one does. But look what the exponent's going to be. The exponent's just going to be a 1. So it wouldn't be 25 because 5 to the 1st power is 5. So it should be this last one down here. Then this one, remember there's a 2 here. So we're going to take 5x and we're going to raise it to the 1/2 power. Your exponent goes on top, which there is no exponent, so that's automatically a 1. Your index is automatically a 2 because that's the square root. Then our fourth one, we've got 5 to the 1/2 power. The 2 goes as the index, the 1 stays on top, and we automatically know that square root of 5 looks like that, and you go the backwards, it's 5 to the 1/2. So any square root is the same thing as that number or variable raised to the 1/2 power. That's exactly the same. So just like in math.
Miss Pledge, please call Miss Browning at 610-17. Miss Pledge, please call Miss Browning at 610-17. Thank you.
Not sure, guys, if that was me or if that was somebody else. So let's finish. So e is 5 to the 2/3 power. So the bottom number goes in as the index goes in the front. Your exponent stays on with the 5. So we've got 5 squared underneath because that stays with the 5. So that turns into 25, and the 3 goes to the front. And that would leave the last one to here. So if you get to the last one and you have the wrong answer, then you need to check your choices because that shouldn't be it. So remember, any square root is the same thing as raising it to the 1/2. So x to the 1/2, that matches, and then plus 5 is just left there. So that is all, Seahawks. Thank you very much.